In this video, we show how to monitor security policies on Android platforms using runtime verification. On the application level, we have an app that runs a monitor for every policy per installed application on the phone. Here you see a list of all applications currently installed and their user ID. When malware executes an event trace that violates a policy, the monitor will raise an alert. The first malware example we show violates the following policy. No application should ever request the GPS location and then send it over the internet to a remote destination. You see an alarm popping up, and if we look at our Runtime Monitor app, the app is marked red because our fake malware has just violated this policy by sending an email containing the GPS location of the device. Here you see the received email with the location of the device. We are now using the OS Monitor application to show logging information of the system and explain which changes we made to the Android platform. We implemented our own kernel module to be able to log system calls, such as the connect syscall that initiates the connection to the internet. So let's look at dmessage, the kernel log messages. Indeed, you can see that we log sysconnect for iNet sockets and this way detect when internet is used by an app, uniquely identified by its UID. We also get information of the IP address from the syscall. Our module is called logsyscalls.ko, as you can see as well in the log file. The information is exported from the kernel via k-objects, which means this information is stored in the virtual sys directory of the Linux file system. Then a new event is sent to notify the framework about the event. Now we look at logcat, the log messages of the Android framework. Here we added a system service called logsyscall_service, which uses an implemented observer pattern of the framework to listen to our upcoming new event. This service sent the information via an intent called event intent to our Runtime Monitor app. Now we are showing a second malware example. It violates a policy: no application should ever write an AMR file to the SD card. Some Android viruses that have this behavior record voice calls of the user and save them as an AMR file. Again, the Monitor app raises an alarm. So let's look at our kernel log again. To monitor write operations to the file system, we are logging and intercepting the open syscalls in the Linux kernel. This way we also get information about the file path that is currently written. Again, a new event is sent. And again, logcat tells us that the logsyscall service has received a new event, reads information from the virtual file system sys, and sent it to the runtime verification app.